So, welcome all the participants of this global virtual conference. And first of all, I would like to congratulate the Japanese success of the H3 launch vehicle mission. And also today evening, just about few minutes back, the India launched the meteorological satellite successfully with the Indian-built launch vehicle and also the Indian-built satellite system for meteorological and atmospheric sciences. So it is opening up a lot of opportunities for many people in the academic world. Okay, next one. As Dr. Murali Krishna said earlier, the small satellite initiative is basically it has come by the advances in the electronic technology and also the improvement in the software and design capability, and at the same time the new materials. So without this, none of these things would have been possible. And the revolution which happened by the CubeSat with the California Polytechnic College, and also the Stanford University and the NASA Ames Center, I think that probably made a breakthrough in taking the technology of building satellites as a classroom experience, and also at the same time successfully launching and operating them for the the entire mission. So this is very, very important to keep that in mind. That very word, it is called the experiential learning. I think that was demonstrated uniquely by the Cal Poly thing, and they made use of the decommissioned the missiles which are to be actually put under hammer. Instead of that, they used to launch the small satellites into orbit, and that has really helped the student community and the academic community in a very big way. And now many countries are actually participating in this CubeSat kind of missions. Not alone CubeSat, but even bigger ones. I think the nano satellites also are there below the 1 kilogram, and also up to 100 kilogram kind of satellites are there. And the thing is, most important thing is it is cost effective. An idea can be tested before actually venturing into operational system. And at the same time, it is the improvement based on the orbital results. I think that is very, very impossible otherwise to wait for a few years to really get a launch and then get the successful results. So here the faster, cheaper, better. Okay, that word which was one of the NASA administrators earlier coined, that is actually demonstrated here in day in and out by the small satellite teams. And the technological advancements, miniaturization, and the important thing is miniaturization was made possible by the electronic technology, and the other part, the propulsion for the building very small thrusters, whether it is making use of the Hall effect or the even decomposing the hydrogen or many other things were actually tested here. But this one very important area where the millinewton thrusters are now becoming very important things for this kind of missions. And in the communication, lot of advances which have happened in the digital communication technology. Now all of them can be tested with this, including the inter-satellite links, also the cloud storage, and many other things are possible in this. Okay, so this one, and instrumentation has shrunk much more effectively, and the Internet of Things is now getting into operational mode because of the small satellite initiative. Next one. Yeah. Next one. Yeah. Next one. I am audible?
Yes, sir, you are audible.
Yes. So some of the initiative which I think India took earlier, it was We had the Indian remote sensing satellite, which was in the class of about 600 to 800 kilogram category, and then even 1000 kilogram category. But the very same capability was condensed into something like 100 kilogram kind of vehicle. So that is called the Indian mini satellite, and it was high resolution Earth observation, communication supporting LEO constellations, and scientific experiments. Many of them were done through this. And now this proven technology has been transferred to Indian industry. So for the commercial customers, there is an industrial way of getting things done through the proven technology. The technology transfer has taken place. And the Earth observation too, this is another, it was further reduced. The IMS one was improved further, and this has been already built and launched. And the very same capability which came from the big IRS Indian remote sensing satellite, it was 1 order less 100 kilogram, and now it is in the 10 kilogram category. Also now they have observed many of these things have been accomplished. And the other part, to cater to launching these kind of things, we have the what we call the small satellite launcher. Small satellite launch vehicle, it is exclusively tailored for getting many of these things into orbit. I think screen has disappeared. You just check. Okay. So this is but this has been already planned and launched. So there are the first launch, there was some small issue, but then further 2 launches, and now it has become a commercially viable means of getting small satellites into orbit. It can go up to 500 kilogram into low Earth orbit, and it has got the capability to launch multiple small satellites with the deployer system specifically designed and built for this vehicle, and orbit can be also chosen, and the kind of things which is, and it is restart capability for changing small orbital changes also are possible. And the other part is what we have seen, the private sector involvement in building these kind of things. So now in Bangalore city itself, we have number of institutions where the students who actually built hardware, tested, now they are actually opening up their own entrepreneurship kind of companies, and it is being done. And also the people who are actually veterans in the field, they are also opening up companies in the aerospace field for building small satellites for the end users, which are at a very low cost and a very short turnaround time. So this is very important to see that the opening up of the space program, as Dr. Muralikrishna said earlier, it has helped also to now nurture this band of youngsters to build cost-effective, timely solutions and also path-breaking solutions. Not the beaten track solutions, but the path-breaking solutions. Okay, next. Next one. Yeah, next one. Yeah. Here you will see the possible use of the small satellites for Earth observation, especially the environmental monitoring. The global deforestation and pollution monitoring. This is very, very important thing, one contribution. And disaster management, this is the post-disaster. Also, very important thing to provide the communication links and also get the assessment of the damage. I think that is very important thing. And the other part is the pre-disaster, the advance warning to be given to move the people to safe zones and also get the timely information about the movement of the cyclones and other things. So this is on real-time basis, it will be done. So this is another important thing which has saved maybe sometime in India itself, I think we have a very major cyclone. We saved almost close to 2 or 3 lakh people are shifted from their homes to safe zones. So this has been one of the possible things for the small satellites also. And the communication areas now, the Internet of Things is the catchword now. And now everywhere, whether it is for the economic development or for agriculture or for the commerce, everywhere the Internet of Things will become a tool. So the health of the equipments and infrastructure can be effectively monitored by the IoT connectivity and also the remote area coverage, because this is where island nations are there, far-flung island nations are there like Indonesia and all 13,000 islands. And even in India, the far-off places and also the border areas where the inaccessible regions, mountainous regions. So many of these things are possible by the small satellite applications tailored for this kind of things. Here it is not alone for the cost effectiveness, but also for the economic development of the regions and give connectivity. I think that is a very important thing. And the other part, I think the space weather prediction, now the solar flare is coming and many other things, even of course India has joined by launching Aditya L1 mission, where it is Indian built spacecraft is going to the Lagrange point and stationed there for monitoring the solar activity. But very similar thing, small satellites also can be used for having the data coming continuously about the space weather, because this is one of the things which I think suddenly it can strike. So that I think the important aspect is how to design payloads for this kind of thing. I think that is the area where the academic community will have a big challenge. And the cosmic ray studies, you might have seen the University of Toronto built small satellites. Institute of Aerospace Studies, UTIAS, they built satellites exclusively. Many of them are tailored for the breakthrough ideas in the astronomy. So this, including cosmic ray and maybe sometime the gamma burst and other things. I think we will have a constellation of satellites can detect the actual strength and also the location of the event in the cosmos. That is another important thing. Yeah. Next. And the launch opportunity, now India is now poised as the opening up of the Indian space program to many, many activities, including the private participation. The piggyback launches, here the launch vehicle can carry some maximum payload, and the particular satellite has got some, it is not really requiring the full capability of the launch vehicle. So the excess capability can be tailored for launching smaller satellites in a small, additional attachments. So this cost sharing, and also sometimes the orbit also can be slightly altered after the main payload is released. The other satellites can be put into different orbits. So this has been successfully demonstrated by the Indian Polar Satellite Launch Vehicle, and now the dedicated launch vehicle which has come for the small satellite launch vehicle, which has got almost 120 tons kind of lift-off mass and about 500 kg in the low Earth orbit. That is the design capability. And it has 3 solid stages and 1 small liquid trim stage, which can put the satellites in the proper orbit. So this, I think, the very cost effective compared to PSLV. This is much more effective for small satellite launchers. So this is, I think, now being offered maybe in the coming this year and next year onwards. I think more launches will happen, and it is paid launches, including there are already people who are actually buying the launch service through our National Space Industries Limited, New Space India Limited. They have already approached for launch on payment basis. and it is very cost-effective launch cost. I think that that is important thing to be noted. It is for whole world. I think the people can bring and then put their payload into orbit of this kind of the small satellite category. Next. Yeah, now the challenges are, the size. As you see, it is a complex interdisciplinary product. It's mechanical, electrical, thermal, you take any area, all the things, and the advanced chemistry, because the energy storage, energy generation and energy storage, solar cells, and also the battery technology, many other things, and then the composite material and 3D printing, variety of technologies are now converging on making effectively a good product for the small satellites. But the miniaturization of the area where we have to really get into the sensors are very critical, because when you are actually going for breakthrough in understanding the nature, you also have to come up with original and innovative ideas for new sensors. So, for example, the methane studies, it is one of the greenhouse gases. So now a lot of studies are going on for how to effectively make a new methane sensor, whether it is for agriculture based, because or it is on the, you can say, the coastal regions where the vegetation is actually, for the kind of things which are producing the methane. So the kind of studies that are required globally, it is required, because it is not merely in one country or one particular area. It has to be everywhere. So what India is now doing, the InSpace, Indian National Space Authorization Center, this is an arm of the Government of India and also the Department of Space. And this is exclusively now gearing up for the encouraging users to come and get the support, hand-holding, and also licensing, and all the formalities to go through, including insurance and many other things, and launch services, and also making use of the ISRO facilities, already well-established ISRO facilities on payment basis. So this is one of the important things, and the regulatory mechanism, because the kind of things that they have to get to, all the both national and international laws, they have to be complied with. So they are making sure that all this will happen. So this is one of the important thing, but in addition to this, they are also nurturing innovation. So this is where I think the innovation, they are opening up, number of outreach programs where the academic institutions are brought together, and also the opening up of the research areas for the funding, and finally come out with a way of getting that product into space and get the benefit. So the entrepreneurship is part of the promotional effort done by the InSpace. This is a very unique opportunity for the people in India, all the academic institutions, because as you know, India has got more than 50,000 institutions, educational institutions in the higher education category, and more than 1,500 universities. And engineering colleges alone are close to about 4,500, and polytechnics colleges equal number. So variety of things are happening, and the management schools are also offering programs for this kind of entrepreneurship and initiative. So here we will get the how to go about. I think there is a hand-holding process which is successfully getting tested now, because it is just maybe only 1.5 years old, this whole process. Now they are successfully coming together with all the things. Then in addition, I was telling earlier that the excess capability of the vehicle was, to be used for building small satellites and getting them launched. Here, what you see on the right side, the picture, there is the fourth stage of the PSLV. It is an equipment bay. Basically, bottom, you will see the the interstage adapter, then the payload adapter will come on top. And on top of that, you have the normal vehicle avionics, which is the inertial navigation system, and also the telemetry, telecommand, and many other things which are normal part of the launch vehicle. But now it is redesigned to work as a doubling up as a space platform for orienting this whole thing and putting payloads which are not necessarily, they are called hosted payloads. So you can build with a new idea, you are finding that you want to test it in space, very quickly you can get onto this. But of course, it depends on the availability of the launch opportunities. And a number of them, very recently also we had, the poem, it is called the orbital experimental module. No, of course, it is nicely condensed as poem, but this is very important to know that it is the success of this program is very well done. And now very recent experiments, they have demonstrated. One of them was on the, the plasma thrusters built by one Bangalore entrepreneurship company, and many other things are also there. And even a star tracker can be tested. Something new product, without waiting for a satellite to accommodate and then get into orbit, you can very quickly complete this program. And this is a grand success. And unlike other things, to this time, they also demonstrated with the remaining fuel, they also made it into to deorbit, brought down to 350 kilometers, and then it was finally it will burn up in the atmosphere. So no debris left in the orbit. This is a very unique experiment which has been done. Okay, next. Yeah, next one. Yeah, international partnership, you will see we have small satellites. We have also tied up with other countries. Sometimes they bring the satellite from Argentina to entire European countries, and also the Canadian countries, Canada and many other places, and Japanese also abroad, and many other countries are making use of this opportunity available in Indian launch vehicle, spare capacity at that time, but now it will become a viable means using the small satellite launch vehicle. And the constellation creation of small satellites, inter-satellite linking, including testing the laser inter-satellite links, and in addition, the storage in the cloud storage of the data, so common pooling, and the network for monitoring the earthquake and many other things are made possible by this kind of arrangement. So this is another area where the academic institutions will have opening up new challenges and new way of looking at things for and the other part, I think they are going to cover it later on. The emerging technology, the onboard system without redundancy, self-healing systems. That is self-healing system. That is one part is going bad, whether you can still survive with the remaining part. Because the kind of things, I think the technology which are now coming, instead of putting a brute force redundancy of identical system to another one, you can make use of artificial intelligence to cover this kind of things, and then the capacity can be restored without much of additional hardware and software on board. And also adding the algorithms, periodically you can update the algorithm. This is another thing because a satellite which is going for geostationary orbit is now designed for 15 years life. So the International Space Station is, almost 3 decades, I think it will be in orbit. So a periodic update of hardware and software is possible. But here hardware is not easily replaceable, but software can be done. New capabilities can come. So this is another area. And then the software docking and then replacing some parts or adding a new payload also can be tested with the new technology of small satellites. And the scientific research, I think now you will see a lot of people talking about the quantum communication. So experiments, ground and also space-based are taking place. And here again, small satellite will be one of the tools which will be effectively contributing for successful results. Okay, next. Yeah, next. So of course, I am not telling about because Chandrayaan 1, what you see, it made history by landing successfully on the moon. And Mangalyaan, we have also got this thing orbiter, which mapped the entire Mars. But now the point is, whether it is big or small, ultimately you have to actually go for the successful mission. And that is where I think the interdisciplinary nature of this entire program comes into a picture. So in India, the engineering curriculum now allows 2 electives, interdisciplinary electives to be taken. So most of the places, I think the small satellite can be one of the good elective for all departments together. And the same thing, robotics also. So space robotics and also the small satellite, I think they are going to probably provide a big opportunity for interdisciplinary learning and also experiential learning, as we have seen were pioneered by Cal Poly and the Stanford University and the NASA Ames. So I wish that we successfully take this message to all across the world for the experiential learning to be effectively demonstrated and also bringing results. Thank you.